Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Refraction of Light at a Plane Surface, that too part A. So before solving the questions, my suggestion is watch the concept video first. Once you understand the concept video, then only we can solve all these questions, or else the words which we are going to use, that will definitely confuse you. And if you have seen the concept video, while solving the question only, you can easily guess the answer, and I will teach you how to write it in a proper way. Before starting our first question, we need to understand some basics, because all the words which we are going to use in the theory questions, we need to understand the meaning of it. Then only we can solve it. Answer. Listen, assume there is a medium 1, medium 2. Both are transparent mediums. Both are transparent medium. This is the separation. Assume this is air and this is water, or this is water and this is air. Anything is fine. Say this cannot be water and this cannot be air, because air cannot be below the water. Correct? Practically it is not possible. Assume this is air and this is water. Now listen, whenever a light ray enters, okay, try to enter the medium. So this is the point of incidence. At this point of incidence, we have to draw the normal. Okay, so this is normal, and without, so assume there is no medium now. Assume there is no medium. This light would have passed in this way. This light would have passed in this way. Correct? Without any medium. Now we have a medium, and this will undergo refraction. This will undergo refraction. Whether it moves towards the normal or away from the normal, this is what we have learned in concept video. Listen. Now few things we need to understand. The angle between the incident ray, this is incident ray, right? Incident ray and the normal is called angle of incidence. Next, the angle between the refracted ray and the normal is angle of refraction. And the difference between, okay, the angle between the refracted ray and the original path of light, this is the original path of light, right? This is angle of deviation. All these things you should know. Okay, see, angle between incident ray and the normal is angle of incidence. Angle between refracted ray and the normal, this is the refracted ray, correct? The refracted ray and the normal is called angle of refraction. The angle between refracted ray and the original path of light, if there was no medium, this would have been the original path of light, correct? There will be no change in path. The angle between refracted ray and original path of light, so this is called angle of deviation. All these basics you should know, because all these things we are going to use it in some questions. Our first question: a ray of light is incidented normally on a plain glass slab. What will be the angle of refraction and angle of deviation for a ray? Okay, very simple. Listen first. If I draw the diagram, then you will understand it properly. This is the glass slab. They are talking a ray of light is incidented normally. What do you mean by that? That means incident ray is on the normal. Incidented normally means incident ray. The incident ray always will draw, see, always will draw like this. This is the incident ray and this is the normal, correct? But they are telling on the normal only it is incidented. On the normal only there is a incident ray. So then what will be the angle? If the ray, incident ray is on the normal, the angle of incidence will become 0. What do you mean by angle of incidence? The angle between the incident ray and the normal. If both are on the same line, then angle between them will be 0. So angle of incidence will be 0, but that is not the question. They are asking for angle of refraction and angle of deviation. If the angle of incidence is 0, then angle of, okay, for the first one, angle of refraction, okay, I'll write it as R, will also be 0. Then they are asking for angle of deviation. Okay, angle of deviation. See, this is the symbol for deviation, and I am using R for refraction. Don't do all these things in the exam, because if you use any short form you are going to lose marks. So both angle of incidence is 0. If the angle of incidence is 0, angle of refraction will be 0 and angle of deviation will also be 0. Our next question, an oblique incident ray bends at surface due to change in speed when passing from one medium to another medium. The ray does not bend. When it is incidented normally, will the ray have different speed in other medium? First, to answer these kind of questions, we need to understand the question and we need to understand few words. What do you mean by obliquely incident ray? Oblique means it is not, see, oblique means it is not perpendicular or it is not parallel to the surface. It is not perpendicular or parallel to the surface. This is the meaning of oblique incident ray. Oblique means there is some angle. There is some angle. It is not perpendicular to the surface. It is not parallel to the surface. So that means it has some angle, some degree. So angle of incidence will never be 0 for oblique incident rays. That is the meaning of that. So they are telling when an oblique incident ray, okay, hits the surface. See, I'll tell you. When the oblique incident ray hits the surface and there is a change in path of direction. Why? Because there is a change in speed. Now we are going to talk about the second condition. When it is passing from one medium to other, the ray does not bend when it is incident normally. So this is the first case. When it is obliquely incidented, the speed will change. But now they are telling if the incidented on normally, okay, on the normal line, okay, then will the speed of light changes? This is the question. See, this is how you need to understand the question. In the first case, it is obliquely incidented, then the speed of light will change. Now it is incidented normally. Now there is no refraction, correct? Because the angle of incidence is 0, angle of refraction will also be 0. It passes straight, in a straight way. They are asking, will the speed of light changes? Answer is yes. Okay, the speed of light changes even though the light is incidented normally. Now we learn something extra about this concept. Very simple, listen. Even though the incident ray is oblique and there will be no refraction. Even though the incident ray is oblique, okay, there is an angle, okay, there will be no refraction. When will this happen? When the refractive index of the medium 1 and medium 2, when the refractive indices of medium 1 and medium 2 are same. Okay, when the refractive index of value of refractive index of medium 1 and medium 2 are same, there will be no refraction and the speed of light will never change. Only in this case, speed of light will not change. But if it is incidented normally, then no refraction but the speed will change. Here also no refraction but the speed will not change because the refractive index of both the mediums are same. Here it is different, that's why it is the speed of light will change. Our next question, a ray of light passes from medium 1 to medium 2. Which of the following quantities of the refracted ray will differ from the incident ray? Okay, first quantity, speed, intensity, frequency and wavelength. Out of all these four, frequency, speed, intensity and wavelength, which will differ from the original point after the refraction? See, only frequency will never change. Frequency will never change after the refraction because frequency does not depend upon the medium. Frequency depends upon the source. This is the reason for that. Okay, why frequency will not change? Frequency does not depend upon the refractive index of the medium or any medium. It only depends upon the, okay, it is because of the source. Okay, it depends upon the source. Frequency of the source will never change. But remaining all those things, speed, intensity and wavelength will change. Our next question, a light ray passes from water to air and glass. In each case, state how does the speed of light changes. See, here in this question we don't have to write the values. Okay, just simple explanation is enough. To explain it properly, we need some basics, correct? See, I'll write it. First, the speed, okay, the light ray is incidenting from water to air. Okay, the first medium is water and the second medium is air. and in the second case it is entering from water to glass. This is the first case and this is the second case. In each the case we have to tell them, state how does the speed of light changes. See, first we need to know what is rarer medium or what is denser medium. Rarer medium means, see, whenever the molecules are away from each other in a medium, okay, the molecules are away from each other, those are called rarer medium. In the different medium, if the molecules are close to each other, those are called denser medium. So in these two, which is rarer and which is denser compared to water and air? Compare water and air. Which is rarer? Rarer is air. Air means the molecules are away from each other, and in water the molecules are close to each other whenever you compare these two. Okay, only these two you have to compare. No, you should not compare with all these things. In this case we have to compare these two. Which is rarer? Rarer is air and denser is water. Whenever a light ray enters from denser medium to rarer medium, from thick molecules, okay, molecules are close to each other to molecules are away from each other, the speed of light increases. Speed of light increases. You have to write it in full form. Don't use the symbols in the exam. Next, then now see water and glass. We hear which is denser and which is rarer. Compare only these two. In water the molecules are little away from each other compared to glass. So this is rarer and this is denser. When the light enters from rarer medium to denser medium, speed of light, okay, speed of light decreases. So up arrow means increases, down arrow means decreases, but you should not use those symbols in the exam, just for your reference. That's it. Our next question, for which color of white light is the refractive index of a transparent medium is least and most? And we have one more sub question. First we'll understand this sub question. Okay, listen. See, for which color of light if the refractive index of a transparent medium is least and most? Refractive index, do you think the refractive index of a medium will changes with color? Yes, always will talk about white color light, correct? That's why always we consider the refractive index of the medium is constant. But whenever the color changes, if we are not at all talking about white color, normal light, okay, normal light, if the color changes, refractive index of the medium also changes. So this is very important, keep that in mind. Refractive index of the medium will not be constant, it depends upon color also. Okay, now they are telling for which light, okay, which color light the refractive index is least. See, refractive index, to answer this question we need to know how this is the symbol of refractive index and this is nothing but wavelength. How refractive index and wavelength are related? If you know this one, relation between these two, then we can answer this one. See, refractive index is inversely proportional to wavelength. That means if the wavelength is more, the wavelength of colors we know, okay, we don't have to remember the values, just we need to know which color has highest wavelength, which color has lowest wavelength, all these things we need to know. Okay, the wavelength, okay, if the wavelength increases, refractive index decreases. That is how we are going to answer this question. They are asking if the refractive index of a transparent medium is least. So for which color the refractive index is least? For the color which has maximum light, maximum wavelength, okay, the refractive index will be least. Then which color of light has maximum wavelength? That is red. Keep this in mind. Red has maximum wavelength, that's why it has minimum refractive index or least refractive index. The red has maximum wavelength but minimum frequency, keep this in mind. And the violet color, okay, the violet color has least wavelength. If the wavelength decreases, what happens to refractive index? Refractive index increases. Then answer for the second sub question. See, which color has more refractive index? Most refractive index, that is nothing but violet. Why? They are not asking why, keep this in mind. They are just asking for the color. That's it. Are they asking for the reason? Then don't write all these things. This is for your reference. Okay, how we got to this conclusion? If the wavelength is more, red has most wavelength, so its refractive index will be least. The first supposition they are asking which has least this one refractive index, and the second supposition they are asking for which has most refractive index. For most refractive index, its wavelength should be minimum. So for a violet, wavelength is minimum but frequency will be more. Keep that in mind. And if the wavelength is minimum, refractive index will be most. And we have one more supposition. Okay, which color of light travels fastest in any medium except air? See, in air or vacuum, we consider air or vacuum. Most of the time they'll use vacuum. If they use the word vacuum, in a vacuum, which color of light will travel faster? In vacuum, all colors will travel in the same speed. Keep this in mind. In vacuum, all colors will travel in the same speed. But here, except air, they are talking about air. That means in any medium. Okay, air means you have to include vacuum also. Air or vacuum will considered as same. So I'll repeat. Which color of light travels fastest in any medium except air? So except air means you have to consider it as except vacuum also. In any other medium except vacuum or air, which color of light will travel faster? If the wavelength is more, speed will be more. Keep this in mind. How speed and wavelength are related? Speed is directly proportional to wavelength. If the wavelength is more, speed will be more. That means which color has more wavelength? Red. So answer for the second question is red. So all these things, okay, they are not asking. Correct. If they are not asking the reason, don't write the reason. They are just asking for the color. Just mention the color. That's it. Our next question. How does the refractive index of a medium depends upon wavelength of light used? And there is one more sub question. We'll do it in the same slide. So because both are same kind. How does the first will go for this question. Question number 6. How does the refractive index depends upon wavelength? Very simple question. This we have learnt in previous question. These two are inversely proportional. You should not write like this. You have to write it like in wavelength and for refractive index as inversely proportional. Both are inversely proportional. What do you mean by inversely proportional? If you increase the wavelength, refractive index decreases. You can write it like this. Both are inversely proportional, or if you increase the wavelength, refractive index decreases. You can write it anyone is fine. Don't write both, and while writing both the answers, if you make small mistake, they'll deduct marks. You're going to get only 1 marks for this question, and if any mistakes in both the answers, okay, always write one. If one is correct, you will get full marks. Why do you have to write both the answers, and if something is wrong, they'll deduct marks. So be careful. Then one more question. How refractive index is related to temperature? How it will depends upon the temperature? Both are same. So again, both are inversely proportional. So this is how you write inversely proportional. If it is directly proportional, just for an explanation I am writing. If both are directly proportional, see, we will write it like this. But this is not correct. Okay, because for this question, these two are inversely proportional. If you want to write directly proportional, this is how you have to write. So for this question, you don't have to write directly proportional because these two are inversely proportional. What is the answer for this one? Question number 7. Temperature and refractive indexes are inversely proportional, or you can write it as if you increase the temperature, refractive index decreases. Any one you should write. Our next question. The refractive index of water with respect to air. Okay. Water with respect to air. Water with respect to air is equal to mu AW, and glass with respect to air is equal to G and A. Okay, so I'll explain all these things, don't worry. Now we need to express the refractive index of glass. Refractive index of glass with respect to water. This is the question. See, first I'll make you understand these things. Refractive index of water with respect to air. Refractive index of water with respect to air. So this is what they have given. Mu A, mu W. glass with respect to air, glass with respect to air, that is G mu A. In both the cases they have common is air, but in the question they have removed air only with respect to glass and water. Okay, when it comes to refractive index, okay, if the refractive index values are given, if the refractive index values are given, keep this in mind. After with respect to what is there? Water, correct? If it is a fraction, now see, after with respect to what is there? Water. What is the value of water? Refractive index of water, it is related to this one, that should go to denominator. Okay, so remaining thing will go to the numerator. This is what we have learned in concept video. This is very much important, very simple. Listen, if the refractive indexes are two mediums are given in the question, after with respect to what is there? Water. What is the water value? This one. This should go to denominator. Okay, and the remaining value obviously will go to the numerator. If the speeds of two different mediums are given, instead of giving the refractive index, this is the refractive index of water with respect to air. If the speed of water, okay, speed of light in water with respect to air is given, then after with respect to what is there? Water, that value will go to the numerator and the remaining value will go to the denominator. This is the difference between refractive index, if the refractive index is given or if the speeds is given. I will repeat one more time. If the refractive index, in both the cases, now in this question refractive index values are given. So here they have given in the form of expression. Okay, if they have given values also, you have to repeat the same method. If the refractive index of two different mediums are given, after with respect to what is there? Water, that should go to denominator, other value will go to the numerator. Instead of giving refractive index, if they have given the speed, okay, speed of light in water with respect to air, instead of giving the refractive index value, if they have given speed value, then after with respect to what is there? Water speed will go to the numerator and the remaining value will go to the denominator. This is the difference between if the refractive index of two mediums are given or if the speed of light in two difference are given. That is what we have learnt in concept video. That is why I always suggest first watch the concept video, then you will understand how to solve these kind of questions. Our next question, fill in the blanks to complete the following statements. Okay, sentences. Okay, first one. Okay, when light travels from rarer to denser medium, its speeds decreases. This is what we have learned in concept video and one of the questions. Rarer to denser speed decreases, denser to rarer speed increases. And there is one more question. The refractive index of glass with respect to air is 3/2 and the refractive index of air with respect to glass will be reciprocal of that. That's it. See, refractive index of glass with respect to air is 3/2. Refractive index of air with respect to glass, it is 2/3. What you call this? This one process as principle of reversibility. See, this question was asked in 2024 board exam previous year. Okay, so what is the name of this one? The answer you can aramse write. What is the name of this process? Principle of reversibility. So all these things we have learnt in concept video. That is how we are writing it in a easier way. Our next question, what do you understand by refraction of light? Very simple question. This is what we have learnt in concept video. The change in direction of path of light when it passes from one transparent medium to another transparent medium. This is the definition of refraction. I will give you the diagram just to make sure you understand it. See, assume this is the normal we have to write it in dotted lines. Now listen, when a light enters from one medium, this is medium 1 and this is medium 2, assume like that. Okay, and both are transparent mediums. When a ray of light enters a transparent medium, from one transparent medium to another transparent medium, there will be change in path. There will be change in path of light. This is nothing but refraction. If there is no medium, this light would have been entered like this, correct? Now because of the medium, there is a change in path. This is nothing but refraction of light. Our next question, what is the cause of refraction of light when it passes from one medium to another? See, what is the cause of refraction? That is what they are asking. Very simple answer, change in speed. Change in speed from one medium to another. other medium. See, because of there is a change in speed, there will be a refraction. So what is the cause of refraction? Change in speed of light from one medium to another medium. That is the cause of refraction. That's it. Our next question, state the Snell's law of refraction of light. See, this is nothing but laws of refraction. This question is never going to change, correct? This is what we have learnt in concept video. That's why we are going to skip it. Our next question, define the term refractive index of a medium. Can it be less than 1? First, we will understand what is the definition of refractive index. Very simple. See, it is the ratio of sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium. So this is the definition of refractive index. Now we learn the exact meaning of refractive index. See, definition will not give us the exact meaning of refractive index. So I'll give you one example. Refractive index of diamond is 2.43. Okay, what do you mean by that? That means the speed of light in diamond. The speed of light in diamond is 2.43 times slower compared to speed of light in air. This is the meaning of it. I'll repeat. The speed of light in diamond is 2.43 times lesser than the speed of light in air. This is the meaning of refractive index. So now can anyone answer, can it be less than 1? It never be less than 1 for a medium. If you are comparing two different mediums, then it can be less than 1. But for a medium, for a single medium, the refractive index cannot be less than 1. Keep this in mind. Why? Because what do you mean by refractive index? The refractive index of a medium will tell us how many times the speed of light in that medium is slower compared to air or vacuum. So it is always greater than 1. It cannot be less than 1 for a medium. If you are comparing two different medium, then there is a chance that we can get the answer less than 1. For a medium, it is always greater than 1. It cannot be less than 1. Our next question, compare the speeds of light of wavelength 4000 Armstrong, that is nothing but violet color, and 8000 Armstrong, that is nothing but red color, in vacuum. This word vacuum is very much important. You will get to know how. And they are asking for comparison. See, for comparison, you have to write the answer in the form of ratios if the values are given. 4000 Armstrong, 8000 Armstrong, the values are given. You have to write the answer in terms of ratios. If the values are not given, you have to write which is greater and which is lesser. That's it. That is nothing but comparison. Here in this question, they have given the values. We have to write the answer in the form of ratios if they are talking about compare. Compare means not which is greater and which is lesser. If the values are given, you have to write it in the form of ratios. That you should know. And in vacuum, we know in vacuum, in one of the questions we have learned, in vacuum the speeds of light of all the colors will be same in vacuum, only in vacuum. In any other medium, wavelength, if the wavelength is more, speed will be more, but in vacuum it does not depends upon the wavelength. In vacuum, all the colors of light will travel in the same speed. If they are traveling in the same speed, what will be the ratio? How can you write the answer in the form of ratio? If the answer is same, okay, then 1:1. 1:1. They are talking about vacuum. That is why it is 1:1. Or else it will be different values, because red color has more wavelength. More the wavelength, more will be the speed. But in vacuum, both are same. Next, we'll go for sub question B. How is the refractive index of a medium is related to speed of light in it? See, first they have one more question. In vacuum or air, that is different. We'll talk about that later. Now in B, how the refractive index of a medium related to speed of light? Speed of light. Okay, speed of light, we are talking about a medium, some separate medium. Then we'll go for vacuum or air. Speed of light, okay, in medium, in any medium, is inversely proportional to refractive index. Is inversely proportional to refractive index. That means if the refractive index is more, the speed of light will be less. Keep this in mind. This is in medium, in some medium, glass, water, all those things. But now we'll go for second one. And in vacuum or air, so there is a continuation. And in vacuum or air, see, in vacuum or air, the refractive index and speed are not related. In vacuum, the refractive index and speeds are not related, because in a vacuum all the color of lights, all the colors, any color will travel in the same speed. In vacuum these two are not related, but in a medium these two are inversely proportional. All these are logical type of questions. Basics are important to solve these kind of questions. Our next question: a ray of light passing from water to medium speeds up, slows down. In each case, give one example of the medium. See, this question it might confuse you, but I will explain you in a proper way. First we'll talk about the first sub question, give one example for the medium, then we'll go for the second sub question. So a ray of light passing from water to a medium. So it is passing from water to a medium. In one medium it speeds up, okay, speeds up. In another medium it slows down. For both the mediums we have to give an example. When the ray enters from water to one medium, when it can speeds up, if the water is denser medium, then another medium has to be rarer medium. From denser to rarer it will speeds up. From rarer to denser it will slow down. If water, if I considered as denser medium, water, okay, if I consider this as denser, which will be rarer compared to this. In water the molecules are close to each other. In which medium, okay, the molecules are away from each other compared to water, that is nothing but air. Compared to water only you have to write whether it is denser or rarer. Okay, when it comes to water to air, when the light enters from water to air, it speeds up. Okay. Okay, this is one example, water to air. And when it goes from water to glass, from water to glass. Why glass? Why? Because we are talking about slowing down. The ray of light, the speed of light should slows down. That means from water to glass. In both the cases, which is denser? Glass is denser, and compared to glass, water is rarer. Whenever the ray of light enters from rarer to denser medium, it will slows down. Now we'll go for the second sub question. State whether the refractive index of a medium is equal to less than or greater than refractive index of water. See, first we have to take the same example. When it speeds up, okay, this is the second sub question. When it speeds up, so refractive index of water will be greater than refractive index of air. Keep this in mind. When the speed increases, when the speed of light increases, that means refractive index. Here we are talking about the first medium is water, then the second medium is air. So in this case, refractive index of water, see, I am using the symbols. You should not use the symbols in the exam. You have to write it in full form, then or expanded form. Refractive index of water is greater than air. Then speed, when it slows down. See, very simple. If the medium is rarer, then refractive index will be less compared to this one. See, which is denser here? Water is denser, so its refractive index is greater than air. In this case, which is rarer? Water is rarer, so its refractive index is less compared to the denser medium, that is nothing but glass. So when it slows down, the refractive index of water, okay, is less than glass. That's it. If it is rarer, refractive index will be less. If it is denser, refractive index will be more. That's it. Our next question: what do you understand by the statement the refractive index of the glass is 1.5 for the white light? See, in the concept video only I told you refractive index for different colors is different. Even though refractive index is based on the medium, it is different for different colors. So most of the time if they don't specify any color, that is nothing but white color only. Now we'll go for this question. So the refractive index of glass is 1.5. What they are asking, the meaning of it, that means the speed of light. So answer for this question is the speed of light in glass is 1.5 times less than the speed of light in air or vacuum. That's it. So what do you mean by refractive index? It will tell us how many times it is slower compared to speed of light in air. That's it. Our next question, a monochromatic ray of light. What do you mean by monochromatic? Single color light passes from air to glass. The wavelength of the light in air is lambda and the speed of light in air is c. Wavelength, okay, in air, c is speed of light, okay, in air, and v is speed of light in glass. Okay, then if the refractive index of the glass is 1.5, this is the symbol for refractive index. See, whenever we write c, that means that is the speed of light in air or vacuum. Keep this in mind. In any other medium except air or vacuum, will go for v. Keep this in mind. So c represents speed of light in air or vacuum. In any other medium, we represent v as speed of light in that medium. Next, this is the symbol for mu, that is nothing but 1.5. Now we have to write down the relation between c and v, okay, and wavelength of light. Okay, first we'll go for one by one. Okay, first one, see, we have to write the relation between c and v. How these two are related? These two are related using refractive index. This is c by v. This is the formula we have learned in concept video. So substitute the values, that's it. So c is equal, see, I'll move this v that side, okay, I'll move this v that side, and we know the mu value, that is 1.5. So c is equal to 1.5 v, that's it. First you substitute the value of mu, that is 1.5, then you move this v that side. So 1.5 into v, that is nothing but c. Second one, what is the relation between the wavelength of light in glass? Wavelength of light in glass. Listen, this is the wavelength of light in air. Then lambda dash will be wavelength of light in glass. So lambda will be, lambda will tell us the wavelength of in first medium, wavelength of light in first medium. Lambda dash will tell us wavelength of light in second medium. That will change when the medium changes, wavelength will also changes. Next, so how these two are related? Mu is equal to lambda by lambda dash. Okay, so this is the formula we have learnt in concept video. Substitute the values. This is 1.5, okay, and mu is given in the question, lambda by lambda dash. So they are asking the wavelength of light in glass we have to find. So you move this one this side. This is what we require. Okay, here in this question we required c, that's why I moved this one. Okay, v here. In this question we required c, that's why I moved v this side. In this question I require lambda dash, so I'll move this one, and I'll 1.5 I'll move this side. So lambda dash is equal to lambda by 1.5. So whichever we required, okay, whichever the physical quantity we require, that should be on LHS, so that you will get a proper idea. This is the final answer. That's it. Our next question, this is an extra question. In an experiment of finding the refractive index of a glass, if blue light is replaced by the red light, blue light is replaced by the red light, how will the refractive index of the glass change? Okay, change means whether it increases or decreases. Give reason in support of your answer. Very simple question. Listen, first thing, what happens if I change the color? The refractive index also changes, but whether it increases or decreases, that is based on what? Okay, that is based on wavelength. That is based on wavelength. See, wavelength of red is greater, more than blue. This you should know. Okay, red color, wavelength of red color light. See, on all the colors, okay, red has the maximum wavelength. That means how wavelength and refractive index are related? Inversely proportional. Okay, these two are inversely proportional. That means if the wavelength is more, refractive index will be less. For this question, okay, answer for this question they are asking what, okay, therefore this one, how will be the refractive index of the glass changes? Answer will be decreases. See, this is the concept. Don't write this in the exam. I am going to teach you how to write. See, how will be the refractive index changes? That decreases. Refractive index will decreases. Give reason: because red has maximum, write it in full form, maximum wavelength, and wavelength, see in the exam you should not use the symbols, this one, this one, this one, you should not use these symbols. Red has maximum wavelength and refractive index are inversely proportional. That's it. Okay, if you write this much you will get full marks. See, this question is for 2 marks, decreases and also the reason. That's it. Our next question, name 2 factors on which refractive index of a medium depends. State how does it depends upon the factor stated by you. Okay, they're asking for 2. I'll teach you all the 3 which is there in the textbook. Listen, very simple. Nature of the liquid. We cannot predict whether how it is related to the refractive index. That completely based on the nature of the liquid. Some liquids, okay, this speed of light in those liquids will be greater than in other liquids. Okay, so it depends. See, less the speed. See, these are the factors, and now I am writing how this is affecting refractive index. The less the speed, more will be the refractive index. That's it. So nature of the liquid we cannot predict, that completely depends upon what liquid is this. So what we can write, less the speed, more will be the refractive index. Next, physical conditions. Mainly we will talk about temperature. So if temperature increases, refractive index decreases. They are inversely proportional. You can write this one, but you should not write like this. If temperature increases, refractive index decreases. You can write this one, or temperature and refractive index are inversely proportional. You can write any one. This one or that sentence. Next, color or wavelength. You should not write color and wavelength. Both are same. If color changes, wavelength also changes. So wavelength, and if the wavelength increases, refractive index decreases. So wavelength and refractive index are inversely proportional, or else you can write it as color and refractive index are inversely proportional. That's it. Our next question, light of single color is passed through a liquid having a piece of glass suspended in it. That means there is a liquid, inside that liquid there is a glass piece inside it, and light of single color. They may use single color or monochromatic light, both are same. Now they are passing a light, single color light in that liquid. On changing the temperature of the liquid, at a particular temperature, the glass piece is not seen. The glass piece is not seen. Now we'll go for the question. When is the glass piece not seen? What condition the glass piece is not visible? Very simple question. See. So when you increase or decrease the temperature, what happens to refractive index? The refractive index will change. If you increase the temperature, the refractive index will decrease. If you decrease the temperature, the refractive index will increase. But we are not bothered about whether that is increasing or decreasing, just changing. Changing is enough. On changing the temperature, what happens to refractive index? Refractive index will also change. So answer for this question, when the glass piece is not seen, when the refractive index of the liquid, see, you have to write it in full form. When the refractive index of the liquid is equal to refractive index of glass. Okay, when the refractive index of the liquid becomes equal to refractive index of glass. You have to write it in full form, expanded form, refractive index of glass, like this. Okay, here also I have to write the full form. Next, this is the answer. Then why is the light of single color used? Very simple question. See, we know for different colors we have different wavelength. If the wavelength is different, refractive index is also different for different colors. That's why what is the reason for this question? Because the different colors have different wavelengths. If the wavelength is different, then refractive index is also different. That's it. Our next question, see, this question is related to multiple images. This we have learnt in concept video. To explain this question, I have to explain the complete concept of multiple images. That's why we are going to skip it. I believe you have watched there. That's why we are skipping it here. Our next question, draw a diagram to show the refraction of light from air to glass, glass to air. In each diagram, label the incident ray, refracted ray, the angle of incidence and the angle of refraction. Okay, listen, this is a very simple question. In the board exam, they may ask you any one diagram, not both the diagrams, but you should know what is the difference between these two. Just changing the name, like this is a glass medium and this is the air medium, all those things everyone can do. What is the main change between these two? That is very much important. That is what I am going to make you understand. Listen. So first we'll talk about air to glass. This is the surface of the glass, incident ray, and wherever we have seen this point, there we have to draw the normal. Now whenever you incident ray, any ray on the surface, some part will get reflected, some part of the light will get reflected. This is called partial reflection. What do you call this as? Partial reflection. Even though we are talking about refraction, some part of the light will get reflected. That is nothing but, okay, partial reflection. Now here the refracted ray, here the important concept is whether it is the refracted ray will move towards the liquids or bend away from the liquid. That is important. That we can answer right using this concept. Okay, so if it is fast, if the light ray after passing through a medium, if it is getting faster, then it moves away from the normal. It moves away from the normal. If it is getting slower after entering to that medium, the light speed decreases. If it is getting slower, then it moves towards the normal. A represents away from the normal, T represents towards the normal, F represents fast, S represents slow. Now from air to glass, rarer to denser, the speed reduces, the speed becomes slower. If it is slower, whatever the line you are going to draw, that should be towards the normal, like this. Okay, like this. So see, this is angle between incident ray. Assume this as A and this as B. Assume this as A, this as B and this as C. A is the, you have to write A, incident ray, B, refracted ray, C, partially reflected ray. Okay, all these things you are going to write. I am just going to draw the diagram. So angle between the incident ray and the normal is I, angle between the normal and the refracted ray is R. That's it. This is what they require. They are asking write the which is incident ray, which is refracted ray, all those things. So you are going to write it here. A, incident ray, B, refracted ray, C, partially reflected ray. Now this is for air to glass. Now we'll draw it for glass to air. Okay, so here I have to mention air and this is glass. Here this is glass and this is air. Okay, incident ray, normal. Now from glass to air, from denser medium to rarer medium. If you don't know denser medium and rarer medium, I think you haven't watched the concept video, or else in this video only initial stages, okay, in the first few questions I have explained what is rarer and denser. That is very much important. When a light travels from denser to rarer, the speed increases. So if the speed increases, if it is fast, what happens? It moves away from the normal. See the difference between these two. See, this is going, okay, moving towards the normal. This is moving away from the normal. And this, sorry, A, B, and some part of it will get reflected, that is C. Okay, so now here angle of incidence I, this is angle of refraction. Again you have to write A incident ray, B refracted ray, C partially reflected ray. That's it. Our next question, a light ray suffers reflection and refraction at the boundary in passing from air to water. Draw a neat diagram to show it. Listen, the previous question only we have followed the same procedure. So instead of air and glass, the first diagram in the previous question we took it as air and glass. Here they are asking for air and water. Instead of glass, just write it water, and the diagram remains same. That's it. Our next question, in the figure below, a ray of light A incident from air to air suffers partial reflection and refraction at the boundary. Again, first and second question only, but there is one small change here. Complete the diagram that we can do. Reflected ray B and refracted ray C, and how are the angles of incident I and angle of refraction are related. Very simple. Listen, first we will complete the diagram. This is the incident ray. On the point of incidence we have to draw the normal. Okay, from this point partially reflected ray they are asking, and we have to name it as B. See, whatever the naming they are telling us to write, you have to use the same naming only. B we have to take as partially reflected, that is what mentioned in the question, that's why we are going for it. Then refracted ray. Now air to water, the speed reduces or increases. The speed reduces, that's why it goes towards the normal. If they see the light, the ray is going exactly straight like this without any deviation, it is wrong, and it is more than half, okay, away from the normal, that is also wrong, because in this question clearly mentioned air to water, so the ray should be towards the normal. So this is the angle of incidence, this is the angle of refraction, and we have to name it as C. Now we have one more sub question. This is A. Completing the diagram, how are the angles of incident and refraction are related? Very simple. Mu is equal to sin I by sin R. This is the relation between I and R. This is the answer for second question. That's it. Our next question, the diagram alongside shows the refraction of a ray of light from air to liquid. Very important word, air to liquid. Okay, write the values of angle of incidence and angle of refraction. The values are given, right? And why they are asking for the values? If they are asking for the values means these values are not correct. What do you mean by angle of incidence? That you should know. What do you mean by angle of incidence? The angle between the incident ray and the normal. Okay, the angle between the incident ray, this is the incident ray, between the incident ray and the normal is called angle of incidence. This is angle of incidence. And they are asking for angle of refraction also, then that means this is also wrong. What do you mean by angle of refraction? The angle between the refracted ray, this is the refracted ray, this is the incident ray, the angle between the refracted ray and the normal, this is called refracted ray. So this is what we have to find. Very simple. See, this complete angle is 90 degree, correct, perpendicular. So if this is 30, this will be 60, and again this complete angle from this point to this point, okay, this angle is 90 degree. If one is 45, the other will also be 45. That means you can aramse write a angle of incidence is equal to 60 degree, okay, and angle of refraction is equal to 45 degree. You write it in the form of sentence. Angle of incidence, angle of refraction, that you should draw. Next, use Snell's law to find the refractive index of the liquid with respect to air. Our answer we can do, see, what is Snell's law? How we can use Snell's law? That is nothing but refractive index is equal to sin I by sin R. Okay. So, sin I, what is I? I is nothing but 60 degree. That is what we found here. Sin I. Okay. Sin function of angle of incidence, that is 60 degree. Sin R, it is 45 degree. Okay. What is sin 60? Root 3 by 2. Root 3 by 2. Then what is sin 45? That is 1 by root 2. Then root 3 by 2 into 1 by, sorry, this we have to take the reciprocal. Root 2 by 1. This will be equal to, see, root 3 into root 2. See, this 2 I can write it as root 2 into root 2. Correct. We can easily remove 1. 2 I can write it as root 2 into root 2, just to make sure I can cancel this one. So answer will be root 3 by root 2, that is nothing but whole 3 by 2. So if you solve that one, answer will be 1.22. That's it. Our next question, what is lateral displacement? Draw a ray diagram showing lateral displacement. See, this question we have learnt in the concept video only in a very easier way and in using the many facts. That's why I am suggesting you to watch that concept video only. If you have understood that, then there is no need to write this diagram here, because the same question, no change at all. And in the concept video we have learnt in depth also. So any question they can create. So this question doesn't have any change. That's why we are going to skip it. Our next question, a ray of light strikes the surface of a rectangular glass slab such that angle of incidence is 0 degree and 45 degree. In each case, draw the diagram to show the path taken by the ray as it passes through the glass slab and emerges out of it. Okay, first we need to complete the diagram. They have given two angle of incidence. First we'll go for angle of incidence, that is 0. If what do you mean by angle of incidence is 0? That is nothing but the line incident ray is on the normal. This is how we are going to draw the normal, correct? But they are telling the angle of incidence is 0. That means angle of incidence will be exactly on the normal line. If the angle of incidence is 0, angle of refraction will also be 0. See, so there will be no change. There will be no refraction. Again, it is going to hit here. See, from air to glass. Okay, the speed reduces. This one you should know. From air to glass, the speed reduces when the same light hits this surface. Here, from glass to air, the speed increases. That you should know. Now we'll write the angle. This is 0 degree, that is nothing but I, and this is also 0 degree. This is I and this is R, and here again it comes out. What do you mean by comes out? That is nothing but emergent ray. This is incident ray, refracted ray, emergent ray. Emergent ray also, the angle of incidence will be, the angle of emergent will be 0. That's it. So this is the diagram. So you put the arrow mark. So here you can write angle of incidence is equal to angle of refraction, that is equal to angle of emergent if the angle of incidence is 0 degree. Now we'll go for the second one. The angle of incidence is 45 degree. Assume, okay, now this is 45 degree. We have to complete the diagram. See, when air to glass, the speed reduces. The speed reduces. If the speed reduces, the refracted ray, okay, will be towards the normal like this. Okay, it will not go in a straight way because there is a medium, and from air to glass the speed reduces. That's why you have to write this refracted ray towards the normal, and once it hits this surface again, okay, there will be a change in path, right? Because there is a change in medium. See, from here air to glass, here glass to air, the speed the speed increases, if the speed increases, it will move away from the normal. That is the difference between these two. Okay, here this refracted ray is moving towards the normal, but this refracted ray is moving away from the normal. And see, this is the angle of refraction, we don't require that, but we know angle of incidence is equal to angle of emergent. Angle of emergent, this you should know. Okay, this is I, this is R, and this is E. That's it. Arrow mark we should show. That's it. Our next question, see, for this question I have completed the diagram because this is based on the previous question, that's why I have completed it. See, complete the path of ray till it emerges out of the glass slab. This one we have done in previous question, that's why I have done before the question only. In the ray diagram, mark the angle of incidence. This is angle of I, this and all we know. Aram say can do angle of refraction, and at the first interface, this is the first interface. What do you mean by first interface? Where is the first change? This is air and this is glass, and here this is the second interface where it is coming out of the glass slab. So here it is a glass and here it is air. Next, how is the angle of how is the refractive index of glass related to angles of I and R? This we know. That is the first second sub question. First sub question is drawing the diagram. Second sub question, how is mu related to I and R? That is nothing but sin I by sin R. This is the Snell's law. Then mark the angle of emergent by the letter E. That is done. And how are the angles of I and R all related? See, here this is about question C. I angle of incidence is always equal to angle of emergent. Keep this in mind. If this is 60 degree, this will also 60 degree. If this is 40 degree, this will also be 40 degree. Keep that in mind. Angle of emergent is equal to angle of incidence. Next, which two rays are parallel to each other? See, this one. See, and one more thing you have to do. You have to write what is A, B and C. A is incident, okay, incident ray, B refracted ray, and C emergent ray. Now they are asking which two rays are parallel. Okay, see, which two rays are parallel to each other, name them. Incident ray, okay, incident ray and the emergent rays are always parallel. Incident ray and emergent ray. Listen, how we can draw this one? Very easy. If assume there is no medium here, this incident ray would have traveled like this. So if this is C and this will be D, you can continue. You can give any name, A, B, C, D, M, N, O, P, X, Y, Z, anything you can give. So C and D, okay, C and D are parallel. That's it. So C represents emergent ray and D represents extension of incident ray. That's it. Now we have to name them. Answer for question D is, see, incident ray, okay, A and E are parallel. A and E are, A means incident ray and C is the emergent ray. This is nothing but naming. Next, indicate in the diagram that lateral displacement between the emergent ray and the incident ray. State one factor that affects the lateral displacement. We know what do you mean by lateral displacement. This is what we have learned in concept video. The distance between the emergent ray and the extended incident ray. This is called as a lateral displacement. So we have they are not asking for the definition, they are just asking for this lateral displacement. So that is what we have done, and they are asking one more question in that. State one factor that affects the lateral displacement. The thickness of the glass. Okay, the thickness of the glass is the factor which affects lateral displacement. If the thickness is more, okay, the lateral displacement will also be more. That's it. So these are the questions and we have answered everything. Our last question, a ray of green light enters a liquid from air as shown in the figure, the angle 1 is 45 degree, so this is 45 degree, and angle 2 is 30 degree, this is 30 degree. Okay, this is the statements and this is the diagram. Now first we have to find the refractive index. Refractive index is very simple. Say refractive index of the liquid we have to find, right? That is nothing but sin I by sin R. What is sin I? Sin 45 degree. Sin R is, what is R value? That is 30 degree. What is sin 45? That is 1 by root 2. What is sin 30? That is 1 by 2. So 1 by root 2 into 2 by 1. So this is nothing but so 2 into root 2 by root 2 into 1. How I got, see I have 1 into 2 is 2. How I wrote 2 root 2 into root 2? 2 you can write it as root 2 into root 2. Why I have to do this? Just to cancel this root 2. Okay, so answer will be root 2. See, when it comes to this refractive index and all, you can keep the answer in the form of root only, or else you can write the final answer, that is nothing but 1.41. See, if you keep it here also, you will get the full marks. Okay, this question is for only 1 mark. So if you keep the answer in root form also, you will get the final answer. No need to get the decimal form. If you write it in decimal form, that is for safer side. So you can do that, or you can keep it at root 2 only. Next up, showing the diagram, the path of the ray after it strikes the mirror re-enters in the air. Mark the diagram and angles wherever necessary. Okay, we'll do that. Now see, whenever a light enters, there will be a partial reflection, correct? So name all those things. A, assume this as B, and this as C. Okay, see this as C. Now see, you have to write A is A, incident ray, B, refracted ray, C, partially reflected ray. Now when it enters the plane mirror here, okay, so there will be, okay, this will be the normal, and this will be the angle of incidence. So this will go back, this will go back. Now what is this angle? See, if this angle is 30, this angle will also be 30 degree, and 1 minute, this is 30 and this will also be 30. Why? Because angle of incidence will be equal to angle of reflection. Once it enters here, okay, I have to draw the normal. Whatever the angle is here, the same angle 30 degree, and now this angle, see, it is now moving from liquid to rarer, liquid to rarer. That means liquid to air, that is from denser to rarer. The speed increases. If the speed increases, the refracted ray will go away from the normal. If this is 30 degree and this will be 45 degree, that's it. Okay, this is the diagram they are looking for with all the angles. Now we'll go for the next sub question. Redraw the diagram if a plane mirror becomes normal to the refracted ray inside the liquid. State the principle used. Okay, I'm going to redraw the diagram. Assume this is the surface, normal, angle of incidence 45 degree, and we have to, this will go here, so that this one, the mirror, it has to be placed exactly 92 degree like this. So this is the refracted ray, this is the point of incidence. So this angle, okay, this angle should be 90 degree. That's it. Now they are asking for the which principle we have used. Principle of reversibility. This is the principle of reversibility. That's it. Now we have completed all the questions from the refraction of a light at a plane surface, part A, only part A. Now we are going to solve the numericals, that is in a different video. All those videos, links for all those videos will be available in the description box. Next we are going to solve all the remaining numericals. That video will also be available in the description box. Thank you.